everybody, it's Tyler here at Kettering Week 1, checking in team number 27, Team Rush, of course, coming in from Michigan, legendary Team Rush. I'm here with Allison, Lauren, and Luke, and you got to check out this robot, what's gone into it. Really just well-made machine. Saw them perform a couple times, getting traversal climb. Shooter's very accurate, so very much so looking forward to going all through this robot here on Behind the Bumpers.
Your destination for first content, updates, and gaming.
Welcome to the fun.
First Updates Now, supported by Stryker Careers. Stryker's commitment to medical device technology innovation has made it a top career destination for those in First. First alumni and mentors are given top priority in their internship and career applications. Come create the next medical innovation that saves lives at careers.stryker.com. Competition season is here. Head on over to thebluelions.com to catch all the events each week. Don't forget to submit your clips of the week to discord.gg/firstupdatesnow. Vote in the FRC Top 25 and play in our free fantasy pick'em. Catch fun shows live on Mondays and Tuesdays at twitch.tv/firstupdatesnow.
So, Allison, we're going to start with the intake here robot. Talk to me about some of the iterations that's gone through it, and you got a really beefy intake. Just what was kind of your decision process between doing a type of intake that you have?
Well, we wanted to try and have some kind of thing that would come over the bumpers and be able to get the balls in. So we kind of designed this to be pneumatically powered. So these rollers will go faster than these ones in order to pick up the ball. And this comes out over the bumpers, and which then they will lead into the ball guide.
When you were looking at looking at these type of like compliant wheels that you're using on there, did you test out different types of wheels? Like kind of like what made you decide to go with this setup for it?
Well, we've tried these Coulson wheels because these seem to be the best ones for picking up the ball in order to make sure the ball actually goes into the intake.
And then from kind of a rigidity standpoint, if you look at your intake there, pretty rigid intake that you have on that. We've seen some teams go with a loose intake, some with rigid. Kind of what was some of your thought process behind what you went with?
Well, we originally had a different material for this, and we decided that it was too rigid and would not work for it. So we kind of actually had it a little bit looser than we think, but it's kind of a polycarb material because we wanted it to be able to move and be a little bit more flexible.
Well, let's move in next into your indexing. Lauren's going to cover that. I'd love to hear more about these rollers that you have, Lauren. Tell me more about it.
Of course. So these individual rollers are made out of plastic tubing, and they're all connected by these little 3D printed Mark Forge gears. So they are all powered by two Neo 550 motors back here, and we have our whole hopper system is what we call it, split into two sections. So this front section can roll freely, and then this back section is static. And when we are ready to launch, this clutch gear is powered by pneumatics, and that will fire and allow these rollers to move also.
What made you want to go with this type of system for your hopper? It's very interesting, something we haven't seen amongst too many robots this year.
So one of the main reasons for the weird shape is our battery is right underneath here, so we had to get over that, so that's why there might be that weird shape. But we also just found it was really effective in getting the balls to the right spot. We had to go through a lot of iterations with both the hopper and interacting with the intake to get the ball in the right spot. So we made these ball guides and also our top deflector to prevent balls from popping out from the top and making sure they get, even if they come in from the side, into the right spot.
So talk to me as we go into your shooter now, talking about that transfer process between your hopper into your shooter and kind of what's gone into everything for it.
Of course, yeah. So I mentioned it before, but we have a clutch gear here. So when our hopper system is running, if we don't want to shoot, then this portion won't be spinning. And then once we're ready to launch, when we're waiting for it to launch, this indexer wheel will hold the ball in the spot in the middle of the robot, so we can have our two balls in there waiting. And once we're ready to launch, with one press of a button, it's all automated, so a bunch of different mechanical processes will go off at the same time. our Coulson wheels will spin up and be able to launch, and this pneumatic will activate our clutch gear, and this portion of our hopper will be able to roll. And for our actual launch, we have a 29-degree adjustable hood. So within these 29 degrees, the hood is able to adjust to any position, which is great because we have our limelight under here, which is being covered by these sunglasses.
I love the sunglasses, awesome.
Because it gets a little bright. But with our limelight, we're able to detect where the hub is, and automatically it can sense where we'll need to shoot. So from our limelight, our hood will automatically adjust to the right position. Our Coulson launcher wheels will spin up to the correct speed. And also we're able to have our whole robot point to the right spot to be able to make a successful shot.
I want to ask you in the back here, what is this light for? Is that feedback for the drive team?
Yeah. So this light shows different statuses of our robot. So if we're launching, if we have balls in the intake, during our climb, I think they flash rainbow. So it's just to let the drivers know what the status of the robot is.
Well, we're going to move on to Luke. He's going to be talking about your awesome climber that you have on your robot. It's been doing traversal every match that I've seen so far. So looking forward to hearing more about what's gone into it and why you decided to go the route you did.
Yeah, we were really interested in climb design this year. So as you can see, we have our two pillars. These are what we call our elevator system. Our robot is lifted up both by these spring-powered, you can see here, as well as we have pneumatic cylinders that will help assist the elevator up. Once our elevator moves up, as you can see, we have a claw in each corner of the climb. We start climbing on the second bar, so our robot will tip the climb up, powered by two Falcon 500 motors, as you can see here, on our 196:1 gear ratio. This allows us to get max torque and power, but still be able to move fast. Once we tip up, we will climb on the second bar here. These are pneumatically powered claws. We'll pull this bar back, as you can see here, which will then close our claws. Once the claws are closed, we will swing under the bar, similar to how someone climbs a monkey bar. We will swing to the third bar, and the same process from the third bar to the fourth bar. One of the main goals with the climb this year was to have a stable climb design. As you may have seen in some other iterations of other teams, when they climb, they swing back and forth a lot, and that was something that worried us a lot. So as you can see here, Isabel can demonstrate our elevator system deploying upwards. As you can see, we're in the first stage. We would drive under the climb bar and have the bar line up right about here. The next stage, we latch onto that bar. After that, we're rotating to the third bar, as you can see here. We lay on and clamp on. From the third bar, we're swinging now to the fourth bar. We'll lower onto the fourth bar, latch on. After that, we will release from the third bar, and that's it. Our climb design this year is very stable with the lower center of gravity. Lauren talked about our battery and our electrical system down there. This allows us to control the speed of our swing as well as the direction of it, so we're not swinging out of control.
So as we wrap up on your robot, I know you mentioned before that you were doing swerve for the first time. So talk to me a little about that experience and anything else on your chassis that you want to mention at all.
Of course. So over the past year, we did a lot of research on swerve, and we made a practice drivetrain that we were able to test out. And we were so excited to learn more about swerve, and it just happened that when we saw the reveal this year, swerve was perfect for this game. So we were able to get a little research before the season, and we were able to implement, these are Swerve Drive Specialty MK4s, and they use two different motors, two Falcon 500s on them.
Well, Team 27 Rush, always a pleasure to speak with an amazing team that you are every single year, and this robot doesn't fail to impress as well, too. So thanks a lot for taking time to tell us about your robot and your team, and of course, good luck during the competition season. Thanks a lot.
Thank you so much.
Thanks to Stryker Careers for their support in this video. Stryker's commitment to medical device technology innovation has made it a top career destination for those in FIRST. FIRST alumni and mentors are given top priority in their internship and career applications. Come create the next medical innovation that saves lives at careers.stryker.com. Don't forget to like, subscribe, and ring the bell to stay up to date on our new videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow. Join our Discord at discord.gg/firstupdatesnow and check out Fun FTC on Facebook, Instagram, and Twitter, and First Updates Now on Facebook, Instagram, TikTok, and Twitter.